In chapter 2, like I said, we were going to explore how to represent that data that we've gathered, organize it, and summarize it. Most likely, and a lot of these things are going to look familiar to you, what we're going to be doing with our data is adding it into some sort of graphical display. Today is not very hard. You've been looking at graphical displays since elementary school, but we are going to be looking at graphical displays. Okay, first, we just need to take some data so that we can use it in class today. We're not filling out a survey for this one. I'm just going to straight up ask you, because what we're doing today is looking at raw data of a qualitative nature and deciding how we can best represent or summarize that information. So what we're going to do is we're going to go from the back to the front, zigzagging through the classroom, and you're just going to tell me which is your favorite elective class. You have 5 options: art, music, athletics or PE, foreign language, or technology. So think right now, what is your favorite? And we're going to start back there with Anthony. Anthony, what is your favorite? Athletics. So everybody, we're going to put a tally mark in athletics to represent Anthony's response. Xander. Athletics. Go, keep going down the table. Foreign language. Music. Art. Andrea. Music. Foreign language. Music. 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 Let's go. Gerson, you're next. Music. Jackson. Technology. Music. 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 Whoa, so many musicians, Kira. Whoa, I'm running out of space. I'm going to come up here. Art. Riley. Athletics. Arthur. Athletics. Hugo. Athletics. Let's go back, Devin. Athletics. Art. Music. Music. Okay, here's an honest question. Where did I mean to put this? Did I mean to put this here? Okay, that's so embarrassing. All right. I'm so sorry whoever's tally mark got put up there. Okay, cool. So we've taken our survey. Perhaps it's your survey question, and you had tally marks to represent the responses from people you got in your survey. What we're first going to do is create what's called a frequency distribution of this data. Literally, you're just going to count them all up. So how many people responded art? How many people responded music? 13. How many people responded athletics? 6. And then 2. And then 1. So that shows me the distribution of the frequency of this response amongst our class, amongst this sample. The next thing we can do with this information is summarize it using what's called a relative frequency, which tells me how much compared to the whole of the sample that response got. And since it's a part of a whole, that means we're making a fraction. The relative frequency is found by the number of responses you got, or the frequency, divided by the total number of responses we got. And we're going to adjust our answer now that she's back. Hey, welcome back. A question for you. Which of these 5 is your favorite elective?
Athletics.
Athletics. Let's adjust our numbers so that everybody's represented. So we'll change this to a 7. Again, now that we're finding the relative frequency, we're just going to take the frequency of this response and divide it by the total number. So how many total people are in class today? 26. So for the first one to figure out what relative frequency art has amongst our class, we're going to type in our calculators, 3 divided by 26. We're going to round it to 2 decimals today. That's arbitrary. I just picked that. You have to pay attention to the problem, see what you should round to. So what is 3 divided by 26? 0.12. Yeah, we're rounding to 2 decimals. So 0.115 would round to 0.12. The next one is 13 out of 26. We should be able to do that one in our head. 0.5. But since it's 2 decimals, we're going to do 0.50. The next one is 7 out of 26, which is how much? 0.27. And then 2 out of 26. 0.07, and then 1 out of 26. Oh, you're right. And 1 out of 26 is 0.04. So again, we have taken the raw data of our responses from the class, that was the tally marks. We created a frequency distribution, counted the responses, and we created a relative frequency, which is a proportion of those responses for our entire sample. Once we have these things, this is where we can start with qualitative data, summarizing it into the classic bar graph and pie chart. I know we know what these are, yes? We've used these since like elementary school. There were more people who responded with music as their favorite than I even left you space on this, so we're going to go a little off grid. That's okay, we can pivot. But what we're going to do is we're going to use the frequency, which is what this is labeled as, to show visually with a rectangle how many people chose art as their favorite subject. I'm using color scheme this time, you don't have to. For art, we said there were 3 responses. That's pink if you care. Also, it doesn't matter. For music, we had 13 people pick music, so even though my graph only goes to 10, we would adjust if I knew that many people liked music. So we're just gonna let it go all the way up here to what would be approximately 13. Nice. Athletics and PE had 7. So we show visually the 7 responses. Foreign language had 2. And technology had 1. Some commentary on this while you're coloring, because y'all know my ability as an artist. These are not technically the same width. Actually, they're pretty good for me. But when we are creating a histogram or a bar chart, you want to make sure that the widths of your columns are always the same width. So if I was doing this for like my final project to show a really good graph, I would actually measure to make sure they're all the same width. You don't want to mislead the people reading your graph. If one is wider than the other, it looks like more people responded because more of that color has shown up, but you're not trying to tell me that. The height is determining the frequency, not the width, so we want to keep the width consistent. My ability to draw is not that good though, so we get what we get. Questions, comments, concern about the bar graph? We've seen these forever, yes? Amazing. The next thing we're going to look at is a pie chart. Now a pie chart, since it's showing you an entire circle, it's always going to be parts of a whole. So for this one, we're not graphing the frequency, we're going to be graphing the relative frequency, because we want to show what percentage of the circle of the responses were each particular response. Now again, if we were doing this for a project, we would actually use the math to find the sector degree. We would use a protractor. We would get it correct. We're going to eyeball it because these are our notes. So for the first section, we want to color 12% of this pie chart the art color. This is where I would actually recommend using color, maybe after you draw it in pencil. But if we're going to represent 12%, do your best. I realize this is hard without an actual protractor. But let's say that 12 is a little bit less than 15. 15 would be a quarter. So we're going to go here. Does that look like 12% for you? Okay. Good enough, shall I say. That's going to be our art. And again, because I'm eyeballing this and I didn't get a protractor out, I'm also going to put the percentage on here so I can see the number as well as the part of a whole for this pie chart. The next section is 50%, because 50% of you guys chose music as your favorite elective. So we're just gonna, is that good for 50%? I feel confident about that one for music, yeah. Okay. The next one, we have 27% for athletics and PE. 27%, let's say, does that look good for 27%? It looks the same as art. Okay, well, let's make 12% a little smaller. I know you probably use markers, so you can't do that. Is that better for us? Okay, again, we would use a protractor if we're really trying to do this correctly. We'll just, again, we're going to label it and put the number so we get what percentage it's supposed to be. This is athletics, which is 27%. Forgive my inability to draw, please. And then we have the last two, which give me 8% and 4%. So 8% for foreign language. I'm just going to use FL for foreign language. Is that okay with everybody? And then our last pizza pie slice was technology, which is 4%. None of that should really be surprising today. We have a bar chart and a pie graph. We've seen these for a while. We should feel okay. But let's add a second variable to the list. So now you can't choose your response on what your favorite elective was. So please remember what you answered. But now I also want you to choose your favorite core subject. So we're going to go back and we're going to split our information amongst math and English. So now you're going to have to tell me two things. You're going to tell me your favorite core subject, math or English. You don't have to pick math. This is not like a who's picking my class sort of thing. Be honest. And then and remind me of which elective you chose, because I'm going to have forgotten. So Anthony, start back there with you. Math or English? And then what was your favorite elective? Athletics. So we're going to put a tally in the section that says math and athletics. Let's go back down the list.
English, athletics.
English art. Andre? I'm sorry, say it one more time. Math and music.
Foreign language, English.
Anna?
Math and music. Math and music.
Gerson?
English and music.
Jackson?
Math and tech.
Music and math.
English and music. Math and music.
I was just looking at this. No, I can't move it. Math and music.
Mommy, athletics and English.
English and art.
Athletics and English.
Athletics and English.
Athletics and math.
Devin?
Athletics and math.
English and art. English and music.
English music.
Nice. Okay, so now we've taken our responses. Do those match up right? 3, 13, 7, 2, 1. Yeah, those match up. Okay, so now we've taken this and we split it by core subject. We can still count the frequency of each response. So for this box right here that says frequency under math and art, how many people picked math and art? 0. Rip. How about math and English and art? Do you see how this works? So then we would have 8 and 5 and 3 and 4 and none and 2 and 1 and none. Now, as we go to do the last column here, we have our frequency distribution, and we need a relative frequency distribution. This time, when we're comparing parts to wholes, we've split our responses by 2 other variables. So I'm not going to divide all of these things by 26 for the 26 responses. I'm going to have to add up all of the maths and all of the English and use those as my denominators or my totals. So in total, how many people picked math as their favorite subject? 12. How many picked English? 14. So we go find now our relative distributions for each option. For finding the math, this one's easy. For math and art, it would be 0 out of 12, which is 0%. Then we would do 8 out of 12. Do you see how this is working? Yes? Can we fill out the rest of this table on our own? So now that we have our relative frequency distribution, as well as our frequency distribution, we can start summarizing this information graphically as well. Now here's an annoying part. The information's on the front, the graph's on the back, and I know you're going to have to flip back and forth. I'm so sorry. In fact, I need to write this stuff down so I don't have to flip back and forth. We're we're going to turn this data, since we split it into two variables, we can split it into what's called a side-by-side bar graph. In a side-by-side bar graph, it's exactly like it sounds. We're going to have two bar graphs side by side so that we can compare the two extra variables that we recorded in our study. Now, we're going to have to draw our own bar graphs for each of the 5 electives for both math and English. So if we look at our frequency distribution for math, and I'm going to use the same color scheme as before. Again, you don't have to. You would have to label it at this point. We said that there were 0 people who picked art and math. So here's my representation of 0 for this one. If I look at the 8 people who picked music and math, I can then draw a rectangle, hopefully of the same width, that represents music. I can then draw a rectangle that represents the 3 people who picked athletics and math. And I'm going to use PE here because we already used A for art. We then had 0 people pick foreign language and math. And we had 1 person pick technology and math. So we have our frequency distribution for this variable. And so we can compare it immediately to those who picked English. We're going to do the same thing for the frequencies of your responses when you picked English as your favorite course subject. So we would have 3 people who picked art in English, 5 people who picked music in English, 4 people who picked athletics in English, 2 people who picked foreign language in English, and nobody who picked technology and English. If I was making this graph for anything more than notes, I would actually get a ruler out and make sure these are equal width. I don't want to mislead the people reading my graph. But for now, this is fine. We could have made 2 pie charts to represent the relative frequencies of both options, but then I'm looking at 2 separate circles. They would have to be maybe overlaid to compare, and it's maybe not the best way to compare 2 different things. So we're still going to make a bar chart for our relative frequencies. Notice now that my vertical axis has changed to be percentages. We made percentages of each number, correct? We wrote them as decimals, but just moved the decimal twice for a percent. So we can still graph the information from our relative frequencies for this information. So if I was going to do this, for the first one, 0% of people picked math and art. So I would give the same 0%. But then I have Ari's favorite number. Say it, Ari.
67.
There it is. She needed to say it. 67% of our respondents picked math also picked music. Are you satisfied? Okay. Then we had 25% pick PE or athletics. 0% picked foreign language. And 8% of respondents picked technology when they picked math. Just do your best on the heights. I get it. We can then do the same thing for the English responses. So art in English was 21%. Music in English was 36%. Athletics and PE in English was 29%. Foreign language in English was 14%. And then our technology was 0%. Ooh, I almost didn't make it on the graph. Again, I would be measuring, making sure it was straight lines, using a ruler. But these are our notes for today. We don't have to be that accurate. Once we have the 2 side-by-side bar graphs, the sort of question we would be able to have commentary on is a question maybe like the one written here. Based on what you see in the graphs above, is there an association between favorite core and elective subject? Before we answer that question, why does it say association instead of causation? Because what?
Because one doesn't cause the other.
How can we prove cause and effect?
You just move it.
What kind of study allows us to say something causes something to happen? Experiment. Is this an experiment? No, what is this called? Observational studies can only have us show an association, not causation. Very good. Now let's actually answer the question. Based on what you see in the graphs, is there an association between favorite core subject and favorite elective subject? So the answer here is actually yes. The only way you'd be able to say no, there's no association, not proving that any particular association exists, is if the bars for math and the bars for English were exactly the same. If they would be evenly distributed between the two, we'd say there's no association because there was no change to our responses based on whether you picked math or English. But were our bar graphs the same? From here to here, they were the same? No, they look particularly different. So the answer here is actually yes. Why am I writing in orange? Answer is yes, because the two graphs look different between the math responses and the English responses. Bless you. Now, the way our data showed up, there's not really an association we can say. The example that was in the textbook, so y'all are defying the odds. The example is in the textbook. Almost everybody who picked math picked the more what are these two? Math and PE, which did actually happen here. And then those who picked English didn't pick those two. They had picked the other ones, which showed a big divide amongst their classes. We're pretty all over the place. So what I would say is that we can't exactly name this association. We would have to have further study. But we can see that they're different, so there is some association involved. We would just have to do further study to figure out what that is, because ours is not necessarily conclusive evidence. Let's go through some vocabulary for today. The raw data that we were talking about earlier is when you did the tally marks. Occasionally when you're taking a survey, you may not organize it as tallies right away. So you might just get a whole bunch of responses, which we're going to see in a little bit. The raw data, again, is the unorganized information that comes from taking a survey. So before you do anything to it, it's called raw data. When you count up the number of each response that you have, that is a frequency distribution. It lists each category and the number of occurrences for that category. Relative frequency, though, is the proportion or percent of those observations within a category. So for the first study we did today, our sample was all in one, so we divided by 26. For the other one, we were splitting it by two categories, math and English. So our relative frequency represented that. The formula that we use for relative frequency is as follows. Relative frequency is equal to the frequency we found of that response divided by the total number of responses in the study or in that category. Frequency divided by total gives me relative frequency. Definitions of bar graph, side-by-side bar graph, and pie chart follow. We kind of get them. A bar graph, you will label each category on the x-axis and frequency or relative frequency on the y-axis. You draw rectangles of equal width, unless you're me and can't draw something equal width to save their life, with the height of each rectangle representing the category's frequency or relative frequency. When it's side by side, you're comparing data for two different groups. And a pie chart is a circle divided into sectors where each sector represents a category of data and is proportional to the category's frequency. We're not going to write a response, we're just going to discuss the response to this next question. When should you use a bar graph versus a pie chart to best display your data? Maybe think specifically about your question for your final project. When would it be good Ari grabbed her question, to represent your data as a bar graph, and when would it be good to use a pie chart to talk about that data? Yes.
What are you looking for the amount of people that answered compared to the amount of percentage of the people who answered?
That is a perfect answer. So a bar graph is just the number of people who answered, would probably be best here. Pie chart, percentage of people who answered something. Because a pie chart shows you part of a whole. So you needed some sort of proportion of percentages. So depending on what you're trying to show me in your data would change whether you use a bar graph or a pie chart. The one thing I want to write down about the pie chart and the when should you use a pie chart, you have to make sure that a pie chart adds up to 100%. So if you're using something and you're just counting numbers, you're not using percentages to show parts of a whole. So the pie chart has to add up to 100% or else it's like a Pac-Man and we want a whole pie chart. You know what I'm saying? I guess I should write more words here. Must add up to 100%. On your next page, we do have some check for understanding questions. Please don't overthink these. This feels like very elementary school style questions. Those of you who are still taking SAT, these are the types of statistics questions that are on the SAT a lot. Again, don't overthink them. The first one says, identity fraud occurs when someone else's personal information is used to open credit card accounts, apply for a job, receive benefits, etc. The following relative frequency bar graph, this time going horizontally, represents the various types of identity theft based on a study conducted by the Federal Trade Commission. First question, approximately what percentage of identity theft was loan fraud, which is applying for a loan in somebody else's name? 5, yeah, okay, like I said, don't overthink it. If we look at loan fraud, which is right here, and we look down to where its percentage is, it says 0.05 relative frequency, which we know means 5%. Part B, if there were 10 million cases of identity fraud in a recent year, how many were credit card fraud, which is using someone else's credit card to make a purchase?
26%.
You're on to something, but that's not the final answer here. So here's what I know your brains just did. You said, okay, credit card fraud is here, so I'm going to look at that value, and yeah, it's approximately 26%. Correct. So I'm not asking you what percentage, I'm asking you how many. So in total, there were 10 million cases of identity fraud in total.
So we need to
Finish your thought.
need to get 26% of this.
Correct. So to do that, you would do 0.26 times that 10 million, which calculate is 2.6 million cases of credit card fraud. So be careful with these questions. Yes, they're super easy. If it asks you percentage, answer percentage. And if it asks how many, find how many. Okay, annoyingly, this next question won't make sense unless you color code or at least indicate to yourself what means what. So I'm going to pause for a second. Yours printed it in black and white, which means we can't read it. So give yourself a second, color code this, and then we'll discuss the questions. Okay, again, don't overthink these questions. We've been reading bar graphs and pie charts since forever. This one says, a random sample of 2,163 adults aged 18 and over were asked the question, when you see an ad emphasizing that a product is made in America, are you more likely to buy it, less likely to buy it, or neither more nor less likely to buy it? Besides determining the individual's likelihood of buying a product made in America, what is the other variable that we have measured in this study? Age. We have this side-by-side bar graph that is splitting our sample by age. Because now we don't just see how many of the entire adult population of this 2,163 people respond a certain way. We've broken it down by age, which allows us to answer questions like B. B has 2 questions in it, so read both. It says, what proportion of 18 to 34-year-old respondents are more likely to buy when made in America? What do y'all think? More likely to buy? Would be about right here. I agree, about 43%. we would hope that this is like, a multiple choice question or like, gives me the number on there if we were really having to put a number, but about 43%. Second question, what proportion of 35 to 44-year-old respondents are more likely to buy when made in America? I agree, about 61%. And again, because we split this by age group, we can answer the questions below. Which age group has the greatest proportion who are more likely to buy when made in America? 55 plus. There were way more people in that category who responded with the blue, more likely. Which age group has a majority of respondents who are less likely to buy when made in America? 18 to 34-year-olds. And since we split this by age, we were able to make some sort of association here. What is the apparent association between age and likelihood to buy when made in America? Exactly. We could say something like older people, the elderly, if you wanted to call it nicely, are more likely to buy products. Oh no, advertised as made in America. It's what this study is showing us. We can't say it's causation because, again, this was not an experiment. This was just an observational study. We would just say there is an association between them.